Greetings, Hacksters! Oh, I'm really excited about today's video. I've been looking forward to opening this one up for a while because I don't know anything about the Arduino Opta system. At least I didn't know until I researched this video. So we've got a cool package here from Blues, who have sent us the Wireless for PLC system. This is an add-on for the Arduino Opta trifecta, which we're going to dive into a little bit. And I'd love to first introduce a little bit about well, first this product, and then a little bit about the Blues system, which we've covered a fair amount on this channel, so you may already recognize it. We'll breeze through that real quick, and then we'll dive into some specifics. So let's check it out. Here is the Wireless for PLC product page. You've got a couple different versions, but they're the same price, cellular plus Wi-Fi, for North America and for EMEA. So this basically takes the Arduino Opta PLC system and adds on the option for cellular or LoRa, which the kits themselves do not have. So the Opta includes you can get a version with Wi-Fi and Bluetooth, you can get a version that's Ethernet only, and you can get a version that is serial as well as Ethernet. They sort of ramp up each one, adding a new option. Let's take a quick look through the product page here. We've got more about the cellular and Wi-Fi connectivity. Right now, cellular and Wi-Fi is your option. Later on, the LoRa version will be available. So it's a relatively inexpensive way to add connectivity to your system, and it can connect with the Blues Note Arduino library, which we'll take a look at later, and the Arduino Cloud IoT Cloud SDK. So you've got lots of options for connectivity. It also connects to a bunch of different clouds that we'll see on the data sheet in a minute. 12 to 24 volts supply voltage. Your communications are powered by the note card system, which is basically a data pump across various different protocols up to the Notehub system, which is a series of notes, aka JSON containing messages that get piped around your system and enable you to shuffle data back and forth up to your cloud, up to other applications, and all works out in a very expandable and manageable way. You can manage your whole fleet on the Blues system. Notehub is the cloud service. Notes are the little packets that go back and forth, and then you can connect it to the Arduino IoT Cloud, AWS, Azure, GCP, and dozens of other cloud services. Lots of good options available for controlling your own application in the cloud. There's also a communication text button and a NeoPixel. We'll take a close-up look at this later on, so I'm not going to read all of this to you, but you can have a look. There's also a bunch of other developer kits that we've covered before on the channel. Be sure to check those out. I've linked a bunch of them in the description to this video, along with this product page and a bunch of the other things we're going to take a look at today. So you'll find the Wireless for PLC quick start here. As you can see, it takes about 60 to 75 minutes to set up from scratch. If you've already done some stuff with the Blues system, you'll probably find it faster. This connects to the Opta via these little doohickeys here, the aux expansion system on the Opta system, which is I2C communication between the Opta and the note card inside of the Blues Wireless for PLC device. Here's some more about the Notehub system, so the communication system that all Blues products provide. They're basically a really efficient way of getting data in between, data and commands in between your devices and whatever cloud you prefer. So you can scroll down through that if you want to see how you get it all set up. We're going to take it out of the box in just a second. Last week we covered the Blues StarNote starter kit, which is a failover method to satellite connectivity, which you can connect parts of your fleet to as well. As far as I know, this isn't yet an option for Opta. They're focusing on cellular and LoRa right now, but that's already a lot to go on. So, but do check out our previous videos for more. On the data sheet, you will find a little bit more about the various protocols. You'll find product images, key features, including the USB-C port is for direct note card programming and debugging, and also more about those different cloud services that you can connect to. As with other Blues options, you do not have an activation fee or a monthly commitment. You do not have to subscribe monthly. You just buy it and then you get data as you need it. Very cool for people who are running things that maybe don't require a huge amount of data all the time, or they go in and out based on, you want to spin it up, might want to, options. You have options. Let's see. I also wanted to point out that there's decent security built into these things as well as into the Opta system. You've got industry-leading security from device authentication through an integrated secure element to encrypted off-the-internet communications and private VPN tunnels. And then you've also got an onboard backup power supply with power outage detection to reduce downtime. There's a built-in capacitor for that. Very cool. Next up, just a really quick look at the Opta system. So it's a micro PLC programmable logic controller with industrial IoT capabilities. This is really the sort of pro side of Arduino. There, as it says in the header there, it's the industrial side where these things are really heavy duty, really robust, and well suited to industrial environments, which is beyond your sort of traditional view of Arduino. This has been going on for quite a few years now, so if you're not familiar with Arduino Pro, definitely look into it. And I wanted to point out that the built-in ARM Cortex-M7, the STM32H747Xi microcontroller with the dual cores allows you to perform real-time control, monitoring, and implement predictive maintenance applications. They wanted to highlight that on the Opta system. Over-the-air firmware updates, various connectivity options, easy deployment, and again, the security options here, we've got an onboard secure element and X509 standard compliance. Cool. Okay, I'm gonna not stare at that. It's very easy to stare at it. But let's take a quick look at the three versions of Opta that are available. So originally, the Blues wireless for PLC system came bundled with an Opta, but this gives you more flexibility and lowers the price. You're just getting the wireless for PLC module itself, and then you can choose what Opta to integrate according to your system preferences. So the Lite is the cheapest one at 146.40, or I should say, most affordable. But this one has, uh, it's got Ethernet and USB-C programming. So direct programming over USB-C and wired Ethernet. Then we've got the Opta RS485, adds serial communication, half duplex connectivity. And then finally, the Arduino Opta Wi-Fi adds Wi-Fi and Bluetooth to your system. So if you get this, the Blues wireless for PLC also adds Wi-Fi, cellular plus Wi-Fi or LoRa plus Wi-Fi. So if you need Wi-Fi, you have options here. You could choose the Opta Wi-Fi, or you could go with one of these lower priced versions and make your cloud even more affordable. I'm going to close these guys because we won't need them. There is a blog post on Arduino's blog that includes some cool examples of applications. So a remote plant, a solar farm, a water well pump, an industrial vehicle, or a large machine like an air compressor that you would want to monitor and control. Again, sensor data and control data back and forth, all this good stuff. Now I'd like to actually get it out of the box. So I do have an Opta in this box, which I'm excited about because that means that I get to click them together. That's going to be really fun. I won't go into this too much, but I'll pull it out because Opta is cool and I'm excited to have a chance to look at it and play with it a little bit. But it is not the focus of this video. Here we go. Your Opta in collaboration with Finder. And then you've got 12 to 24 volts DC in. You've got little power in, various GPIOs, indicator lights. You can figure it out. USB and Ethernet here. Doop. And then more little control guys out. And then here is our aux guy. Oh, do I have to pry this out somehow? Yeah, it looks like it's got a little cap on that. We'll see how I do with that. I've got some tweezers. It'll all be okay. So then we have the Blues Wireless for Arduino Opta. And this has been renamed to Blues Wireless for PLC because it doesn't have to be an Opta. Who knows in the future? Actually, I'm not sure what the motivation was for changing that. But yeah, ooh, we've got multiple antennas here. We've got two antennas in the box, and we've got, come out of here. Oh, I see there's like a little fold out guy holding it in place. Let's get that out of there. And I'm just gonna tip this out. Whew, there we go. Cool. And there's a QR code. I believe this is for device registration and setup. Again, you've got those. These are daisy chainable with other expansions for the Arduino Opta system. So you could stick these together and then stick a bunch of other stuff together, depending on what you're trying to do with your system. I'm going to go ahead and attach these antennas. I was interested. They mentioned in the quick start or something that one of them specifically might be more difficult to get on there, and I'm curious as to why. But we're gonna first let's take a little quick tour of this actually. So um, looking at my little device map here, we've got power supply in, 12 to 24 volts DC. We've got a status indicator NeoPixel RGB LED. We've got a communication test button. Oh yeah, I'm gonna gotta do that up by the microphone. Main antenna for LTE Cat 1 and LoRa. Diversity antenna for LTE Cat 1. Then we've got the expansion port over here that connects to the one that I'm going to pry out of here. And on the other side, we've got the output one. We've got the device provisioning QR code, an external SIM slot, so down here, external SIM slot and USB-C, again, for direct control and programming. We, inside of there, have a lithium-ion capacitor for power loss alerting, and as I mentioned before, it's got sort of a power backup system, and the expansion port out. So let's it's so interesting the way these things are shaped. As I mentioned, I'm really not familiar with PLCs at all. I haven't done much with that at all. So I'm a little curious about how all that works. And like, is this a normal shape for a PLC? I wouldn't know. We are learning together. So I'm gonna try using a tweezers here. What's the deal with this? How do you get this out of here? Because I really want that satisfying moment of like clicking them together. Aha! I've managed to wedge my tweezers under here. And someone out there on the internet is cringing really hard right now. It's not supposed to break off, is it? Ooh. I might look at the quick start actually and see if this is included in there. I obviously don't want to mess up the connector. Okay, it does appear to actually lean out here and possibly snap off. What happens if I push it? Yep, it snaps off. That may or may not be what you're supposed to do, but it's what has happened, so cool. It looks like it's rigid plastic, so I'm not surprised. And then we've got, along with the aux connector, a number of physical, mechanical connections here, so not all that stress is going to be going onto the connector. I mean, you'd be fastening this down to something anyway, but lining up our little slots here. Oh, it's got like snap guys, so you could open this up as well. See these? Let's line this up. I think we can just push them together. There we go. Oh, moment of truth. Well, they do seem to be together. There isn't like a big snap moment that I have yet detected. I'm just going to make sure that I'm actually lining up the connector itself. Because, okay, connector is verified to be lined up. It's just taking a little more pressure than I would expect, but that could be because of some of the additional mechanical contacts. There we go. All right, so, yes, Rob says probably a breakout like an electrical box. Man, that brings me back to a side story. When I was a kid, my dad would give us an allowance based on chores and good behavior and stuff. It was just a couple of dollars a week, but it would be determined based on he had these knockouts from electrical boxes that were like little quarter-size pieces of metal, little round pieces of metal from electrical outlets connections, and he wrote like some kind of legend on them that had to do with chores, and that's how we got our allowance. So I don't do a lot with like home improvement and construction type stuff, but that just unlocked a core memory for me, so thank you. So yeah, there we go. I'm gonna actually go ahead and take these apart again because I want to attach these antennae. The knurled ring does not want to spin on its own, so we're just gonna do this. And it's possible that's why it said to use the pliers. That seems pretty easy to finger tighten. Now, is this one supposed to be harder for some reason? It seems pretty easy, honestly. Does it rotate? It does not rotate! Maybe that's why. Yes, okay. I see now. Whichever one you put on first, you're gonna need pliers for the second one. This is what the instructions said. These are my grody tape wrapped pliers so I don't mar things. Let's hold this down and just spin this. Keeps you from getting those little jagged ridges and bite marks on your stuff. I used to do a lot of chainmail, and you don't want your chainmail to have all these little snags that are gonna grab onto your clothing and your skin and whatever. And it just doesn't look pro, does it? Tape on your pliers, on the other hand, looks super pro, obviously. Okay, cool. I see now where they were going with that. And you got these cute little... The cuteness, I do not believe, is a functional element, but it is definitely a bonus. There we go. Let's take another look at some more features. So here's the diagram I was going off of. This is available on one of the docs pages that we'll look at later. I pulled up the chip info here, the STM32H747XI that the Opta system is based on. I feel like there was something specific I thought would be interesting to highlight here, but in general, you can see that it features 3 ADCs, 2 DACs, 2 ultra-low power comparators, a low-power real-time clock, a high-resolution timer, 12 general-purpose 16-bit timers, etc. You can look it up. There's a cool Blues announcement page here, wireless from PLC expansion blog post from TJ Van Tol. Definitely read through that for a really quick overview that covers the really important stuff. And I think that that's where I got this diagram specifically with all of the things marked. So if you want to take a deeper look at that, go ham. And I like the Lego comparison that they make. So they mention here, TJ mentions here, that you can use either the Note Arduino library or the Arduino IoT Cloud SDK, which actually links out to a Hackster project. The Blues team has a ton of tutorials and projects on the Hackster, their Hackster platform page. So besides going to the Note Arduino GitHub here with a nice README, and checking out their built-in documentation in the Blues documentation page about their Arduino library with a really nice walkthrough, Arduino IDE or Platform.io. You can also go on Hackster to the Blues platform page, or just search up in here for Blues, and you'll find all kinds of cool little projects. Really interesting stuff. Control your smart home from anywhere, overhead tank water level monitoring using Blues, all kinds of different stuff. Trail cameras, remote birding, and yeah, this tutorial by TJ, bringing Arduino Cloud to every device with Blues Note card. That's the one that's linked from this blog post, the Arduino IoT Cloud SDK connection. And he shows you a little bit more about so this is with the Cell plus Wi-Fi starter kit. And you can see a little bit more about that cellular note card. Cellular plus Wi-Fi note card. They have one that's cellular only and one that's Wi-Fi only, and then also the LoRa one and the Star Note for satellite connectivity failover. But this is the Cell plus Wi-Fi. And then also there's a tutorial from Brandon around adding cellular to any PLC with Arduino and Blues. That's for this specific kit. You can see a whole little rig there. Oh, that's so cute. I love how it's mounted to that rack. I know that's not the most, let's say, technical description of this project, but I cannot deny the cuteness of these rabbit ear antennas. I'm sorry, it's just impossible. Very cool. Really great pictures. The Blues team does an awesome job of documentation, and it's what we love to see in a project. Assembling the hardware, etc., and all kinds of good stuff. So be sure to go check out the Blues platform page for more cool projects. You can look by product. So if you have something already from Blues, you can go see all the projects that use that specifically. Good stuff. And then also, they have a webinar that happened earlier today, but is now available on demand. Revolutionize industrial control by deploying anomaly detection models in PLCs. So again, the Arduino Opta, they're advertising as great for predictive maintenance. Similarly, Blues has this webinar about anomaly detection, really good for industrial settings. You can register now and watch it on demand. There's a little bit more about the webinar itself. And then also they've got another one coming up, the Get Started Using Cellular, Wi-Fi, LoRa, and Satellite IoT with the Note card on November 6th. So stay tuned for that one if you want a more sort of broader overview of the Blues system in general. And overall, I love it when Blues sends us stuff because their documentation is scrumptious and I love looking at it. Like both the stuff that they have on their site and their readmes on GitHub and their Hackster projects. I'm a sucker for documentation. I've been doing it since like 2009 when I got into like doing my own blog for documenting projects. And so when I see it done well, I'm just like, I want to reward that. I want to celebrate it. So thanks to the Blues team, both for rocking it documentation and for sending us this kit, which, again, I think it'd be really cool to pass this on to someone who has more experience and more of an application for PLCs. But in the meantime, I'm gonna really enjoy just like looking at it as it sits there. uh, I've got a couple of Halloween projects that I'm working on, but someday I would love to get more time to play around with PLCs. And when I do, perhaps I'll reach for this one. So thank you for joining me. Thanks again to Blues. Hack on.